In this episode, Sasha and Keoni verify that the point 4, 4 is the same distance from the focus as it is from the directrix.
I'd like you to go to the point 4, 4 and use the definition of a parabola to justify why it's on the parabola.
Go ahead.
Okay, so then we know it's going to be, how many spaces? 1, 2, 3, 4. It's 5 spaces away from the directory. So this distance is going to be 5, 2.
You can try it in, Sasha.
Like this
Or
part.
try.
Okay, it's like that part is going to be equal to that part. They're both going to equal 5.
5 units.
Yeah, right? That's going to equal 5, and that's going to equal 5.
Do you think that does equal 5 units?
I don't know. It doesn't look like it, but
It should.
That's your task. You need
great.
to...
you have a ruler. I'm going to measure it.
Well, we don't need a ruler if we have this stuff right here.
Yeah, but then we can double check it.
True.
Like what we did with the first one.
I don't know. Wow.
Okay, so it's like
I'm
4, so
stumped.
1, 2, 3. Not it.
No, because see, it's like 3 up and then 4 over here. Because this is just 5 units away from the directrix.
Uh-huh.
I don't know how to find the distance between these two. Great.
Can you mark down everything you do know? I heard you say something about a 3 and a 4.
Okay.
Maybe you can start by labeling where those are.
That color?
Okay, choose a different one then.
So our point right here is 1, 2, 3 units up, and then 1, 2, 3, 4 units to the right. Whereas this point is just
5.
1, 2, 3, 4, 5 units away from the directrix. It's crazy. 3 units. That was 4, right?
Yeah.
So why don't we try to just take stock of where we're at? So what is it that we're trying to figure out?
The distance from the focus to the point.
Yes.
Right?
And what would you like it to be?
I'd like it to be 5.
But you have to verify that, right?
Yeah.
Okay. And you have many things here that you know. Can you summarize those? What do you know so far?
So we know that the point 4, 4 is 5 units away from the directrix. And then we know that the focus is 3 units down and 4 units over. What else do we know, Sasha?
No, I agree with you.
Is there any math formulas or methods that might be useful to use here to determine whether that distance is 5 or not from the focus to that point? Now, if you could find a right triangle, then the Pythagorean theorem might be helpful.
A squared plus b squared equals c squared.
Okay, so we have 3 units here, 4 units here,
And that's your hypotenuse, and that's
and
c.
there's C.
Yeah.
A squared plus b squared equals C squared. Yeah?
What's that?
Would be,
Okay.
Yeah.
Okay. Well, no, because it's like that. A squared plus b squared equals c squared.
Yeah.
And
So we're trying to find that, and that's going to be
so that's our c,
squared.
because that's the hypotenuse. Because that's always from the right angle, 2, right there. Okay, so what, 3
Is
squared?
that how you remember
plus
this C?
4. That's what they taught us in
Okay.
elementary school. Okay, 9.
Plus 16 equals C squared. 25. It's 5.
Yay!
Right? It's 25 equals C squared. So C squared is 25.
Oh my gosh, look at us, we're so smart. Boom.
Sasha and Keoni made use of the Pythagorean theorem to find the distance from the point 4, 4 to the focus. First, they identified a triangle with a right angle. The Pythagorean theorem relates the sides of a right triangle. The length of the hypotenuse is often represented by the letter C. The lengths of the other two sides are represented with the letters A and B. The Pythagorean theorem states that the square of the hypotenuse is equal to the sum of the squares of the other two sides. Sasha and Keoni substituted the length of 3 for A and 4 for B. They solved for C, which was 5 units. This means that the distance from the point 4, 4 to the focus is the same distance as it is to the directrix. So the point 4, 4 fits the definition of a parabola. In the next episode, Sasha and Keoni use both the Pythagorean theorem and the definition of a parabola to find a missing value for a point on this parabola.